Today we're basically going to just review what inverse functions are. Remember, an inverse function is a function that undoes the original function. Inverse functions only exist in one-to-one functions, which means they pass the vertical line test, which they have to be a function, but also pass a horizontal line test. So in other words, a parabola, a quadratic, is not a one-to-one function because it does not pass the horizontal line test, because a horizontal line would cross it more than once. So basically, if you're looking at it symbolically with your functions or equations, you switch x and y, and then you solve it for y, and that tells you what your inverse function is. Now, keep in mind when you're looking at the domain and the domain and the range of your inverse function is switched compared to the domain and range of your original function. Now, if you were going to go ahead and graph your original function and your inverse, they are just reflections of each other over the y equals x line. Now, there's one other thing that you should be aware of for your inverses. If you take your original function and plug it into your inverse composition of functions, it should simplify down to x, or vice versa. Taking your inverse and plugging it into your original function, it should simplify down to x. So with that in mind, let's go ahead and find our inverse functions. Now, we can find our inverse function of this by just switching x and y. Remember, f of x is the same thing as y. You can also then solve it for y. So to get y, switch x and y. Now we solve it for y because we switched our x and y around. So we'd have to add our 6. And then we'd want to get rid of timesing by 3/4. So we'd multiply by the reciprocal. And then we would get this here. Now, if you wanted, you could distribute that through. We started out with function notation, so you'd want to write this as an inverse. Now notice that this right here matches exactly with what we had up here. So that's one way you can determine if they're inverses. A second way you could do that would be to take this right here and plug it in right here. So if I take f, if I write this out, and then we take and plug in g into that spot, if this black and green thing simplifies down to x, then they are inverses. If I distribute this through, I get x. Distribute it through here, I get plus 6. Still with the minus 6 over here, it gives me x. So that's a second way I could have determined if these were inverse functions or not. Looking at the next one, you can just find its inverse. So once again, f of x is the same thing as y. And then you switch x and y and you solve it. So we'd have to square both sides. We'd have to add 3 to both sides and then multiply both sides by a half. This would be then our inverse. Now, we're also asked to find the domain and the range. Now remember, your range is what you get out. Looking at this here, we have a positive in front of our root, so we're only getting out non-negative, so greater than or equal to 0. Domain, remember your domain, you can't have a negative inside of your root, so you go 2x minus 3. Has to not be negative, so 2x minus 3 has to be greater than or equal to 0. Solve that for x, so you'd have to add 3 divided by 2, and you get your domain to be greater than or equal to 3/2. Now, because we're looking at a range here, when you switch your x and y, it really switches these two here. So when we're looking at our inverse function, our domain of the inverse is x is greater than or equal to 0, because that comes from this, because we switched our x and y. Our range of our inverse, because we switched x and y, comes from this, and our y would be greater than or equal to 3/2. Then on the next page we have one more theorem. Some things in this class we officially have to cover for the college, but we don't really do a whole lot with. This happens to be one of them.